Okay, everyone. Okay. Good evening, everyone. Once again, let us start the class. Class hours are gone. I think everyone is. So I'm going to start sharing the screen. Today's lecture will be. It is going to be the third lecture, and today we're going to talk about the Bohr's model. In the previous classes, I think I have given some introduction regarding the structure of atoms. Today, we are going to come to the topic that is Bohr's model of atom. So, unit number 2, structure of atoms. This is the third lecture and it carries 8 marks. Unit number 2 is very important, structure of atoms. In the previous classes, we have seen how electrons were discovered, how charge by mass ratio were performed by Mulliken, then Rutherford's scattering experiment. You have learned this in your lower classes. Thomson's model was rejected because of lack of valid scientific information. Then we have discussed so many things about electromagnetic spectrum. So in the previous classes, ako'y kay matang binigyan haibado noy kitang samlap na so who is going to answer the question in the previous classes kay taki kay albedo kitang summarize to.
Plus the wave nature of light the visible spectrum range from 400 nanometer to 700 nanometer the photoelectric effect have the when light strike a metal surface it generates an photoelectrons with frequency higher than threshold frequency. This phenomenon is known as photoelectric effect. Minimum frequency threshold frequency
Okay. So photoelectric effect. So what is photoelectric effect? The phenomenon of emission of light when light strikes a metal surface, and that emission of electrons, those photoelectrons, they are going to be emitted only when your frequency of incident light is greater than minimum frequency called threshold frequency. And I have given some homework question also. I believe you all submitted your assignment. Gaizina submit already. Very good. Then where is your friend Nivia? Submit already. Information people. Okay, we'll continue with the topic. Today's class is going to be about Bohr's model. Sige topic siya important no lagi syllabus siya dagi hawgo ni ko asing ko na di. But ang mga high give sing na just introduction part na high the sing ni. So Bohr's model of atom. We're going to analyze this topic today. So oversee Bohr studied the atomic spectra of hydrogen and based on that he proposed his model, which is also called the Bohr's model. And this model is applicable to hydrogen atom or hydrogen-like species. So for example, hydrogen-like species those species which has only one electrons. Okay, so for example, I have hydrogen here. Hydrogen has how many electrons? Only one electron. And how many electrons are present in helium ion? Only one electron. Lithium ion, only one electron. Beryllium, all one electron. So those species which have only one electrons, they are also called as hydrogen-like species or hydrogen atom. This way, electron. So atoms which have only one electron, we call them hydrogen-like species. And this Bohr model is applicable to hydrogen-like species. So Bohr's postulates nucleus is the center of the atom, and around the nucleus electrons revolve in a circular path just like the planetary motion around the sun. And we're going to talk about the radius of this atom. We're going to see the various derivation given by Rydberg and its equation. So how is it called? This is the introduction of Bohr's model. Okay, the first postulate which you have to remember, which you have to keep in your mind is atom consists of a small heavy positive charge called the nucleus. in the center, and the electrons revolve around it in a circular orbit. So atom is the very small object. In fact, it is the building block of all matter. Matter types what are they? Solid, liquid, and gas. Solid, liquid, and gas. We get atoms. So when we analyze this atom, Bohrs says that for hydrogen-like species, atom consists of small, heavy positive charge called nucleus in the center, and electrons revolve around it in circular orbits. See, point center nucleus, just like the sun at the center of the solar system. Planets, they are going to revolve around the sun in the same manner. Electrons, they revolve around the nucleus. So nucleus ka yam nakna leba orbit sa, is it going to be the orbit which have the smallest energy, or is it going to be the orbit which have the highest energy? Can anyone tell me? Why nakna leba orbit sa energy wangadra, energy energy name na layam gadra? So as you keep on increasing, the energy keeps on. As you keep on increasing the energy cells, energy so energy cells are given numbers. Postulate first point, atom consists of a small, heavy, positive charge called nucleus, and this nucleus is the center of the atom, and electrons revolve around the nucleus in circular orbit. Then point number two, says that these electrons which revolve around the circular orbits, they have particular energy levels. These energy levels are assigned numbers. Sige numbers, we call these numbers as principal quantum numbers. Muna tao ko ay unit number 3 taku matam the principal quantum number habis yam to ina palakini. Unit number 2 say khamdragadi akoy unit number 3 4 5 6 7 lai mi am se koi gyan tab kar one thokani. So unit number 2 is very, very important. Pay attention. Electronic configuration electronic configuration no problem face chemistry. So let us come to our point. Electrons revolve only in those orbits which have a fixed value of energy, which is called principal quantum number. Sige numbers, we call these numbers as principal quantum numbers. N equals to 1, first energy cell. N equals to 2, second energy cell. N equals to 3, third energy cell, and so on. It keeps on increasing as you go farther and farther from the nucleus. Energy keeps on increasing as you go far and far from the nucleus. Okay, this is point number 2. Then point number 3 point number 3 point there are subheadings, subpoints of point number 2. Postulate number 2 gimagi subpoints energy. Let us talk about energy. So energy possessed by electron will be given by a formula called Rybak's formula. Okay, so before coming to what is Rybak's formula, Bohr will give some important explanation about the energy possessed by an electron, which is given by the equation En equals to minus RH all into Z squared divided by N squared. Don't forget this formula. Remember, what is this En? Energy possessed by electron in the nth principal quantum number. Electrons in a energy cell ani subada layeragadi akoina kamai igadagi hai kanda, you can write this as E2 is equals to minus negative of RH. What is this RH? RH is called Rybak constant. Okay, whole into kanachangani, whole into Z square, okay, divided by N square. What is this Z square? Z square is your atomic number. Okay, Z square atomic number ni, N square principal quantum number ni. So now can you tell me the relation between energy and principal quantum number? If you keep on increasing the principal quantum number, energy will keep on decreasing, as I have told you before. This energy is now inversely proportional to principal quantum number square. As you go far and far from the nucleus, as you keep on increasing the principal quantum number, energy will keep on decreasing. Energy will keep on decreasing as you increase the principal quantum number. But principal quantum number si yamagadi kidoni, principal quantum number si yamagadi energy si koi wangani. Okay, so know this relation, energy versus, but this is a negative value. So you can say that minus the it is inversely proportional to n squared minus value. What is the significance of this negative value? So what is the value of Rydberg constant? Rydberg constant, and its value is 2.18 10 to the power minus 18 joule. So Rydberg constant की value से क्या नो 2.18 10 to the power minus 18 joule. Then that Z is your atomic number. And if you simplify this equation, when you put the value of RH की value से हप्चन भी ऐसे क्या आता है 2.18 into 10 to the power minus 18, and then Z square divided by N square joule per atom. This will be the value of energy possessed by an electron. So if I say find the value of the energy possessed by, okay, all of you write down the question. Find the energy possessed by an electron in the hydrogen atom with principal quantum number equals to 1. With principal quantum number equals to 1. So without even solving, quickly tell me the answer. Answer yam lai re si khot chu yare answer dum lai ra po ni. Noi si question si bahut kidoro. Are you still going to calculate this question? Question na kay haige, find the energy in the first principal quantum number. Kya hoga doi no? Answer si ba? Minus 2. Minus kay no to. Haro answer kya hoga dage? Minus 2.18 into
10 to the power minus 18.
Yeah. So the lower answer se. Kay maram gino hydrogen gidi atomic number 1 ni ko. 1 square di 1 lai re. First principal quantum number di always 1 ni. Ano hot to sure are ba. Yam thuno noi time management ji khanga da ni ko. Simple question se. Multiple choice question da ko matam. Need or z tha gi ha ga di noi time management yam important hoy. It's very important. You have to take care of time. Then postulate number 1 ha gi bu hoy kaw ga de. Inside an atom, there is a nucleus at the center, which is positively charged, heavy positive charge, called nucleus. And around the nucleus, electrons revolve in a circular orbit. Point number 2, these energy cells are given numbers called principal quantum numbers 1, 2, 3, 4. Then subheading number A, what does it say? Energy in the nth orbit is given by an expression En equals to minus of Rydberg constant Z square divided by N square. So when I say Rydberg constant is equals to minus 2.18 10 to the power minus 18, then I can write the new expression as ANOVA expression. The new expression will now get modified to the value of Elani. What is the new expression? We're going to get this value En equals to minus 2.18 10 to the power minus 18 joule per atom. And then point number B, point number 2 ki subheading ni ko lagisa. What is the second subheading? Radius of the stationary states. The radius of the stationary state is given by another expression Rn. What is this Rn? Radius in the nth orbit. Nucleus tagi masing thiba hodoine 1, 2, 3, 4, 5, 6, 7, 8. So this n is the principal quantum number. So you are going to assign values. If principal quantum number is 2, if principal quantum number is 2, R2 equals to 52.9 divided by Z into kaya laka ni sida kaya laka do ino
2 square.
2 square. Good. 2 square. Adagi picometer hai di keno 10 to the power minus 12 meter hai. So hapchan biro sige values aduga radius in any orbit putupi arakadu. Kangani ko. So radius of the stationary state according to Bohrs postulate number 2 subheading B in high is Rn equals to 52.9 okay n square divided by Z picometer. So keep this point in your mind, don't forget this. So for hydrogen atom, we already know that hydrogen atomic number is always 1. Hydrogen ki atomic number se kya no 1 ni. Thus the radius of the first stationary state. Radius of the first stationary state is called Bohr orbit. So now can I substitute the value of n here? N ki value se lagi ko. Let me put the value of n equals to 1. Lagi. N equals to 1. What will I get the new value? I will get R1 equals to R1 equals to 52.9 divided by kalani sida 1. Okay. Into kanalani sida 52.1 divided by 1 into 1 square. Adu di answer se kya tani? Answer se kya tani haro? 52.9 tani ko. Okay. So sige 52.9 taba answer sibo koina kanagi value nine. This is the radius of the first stationary state. My maming sinakay. What is the radius of the first stationary state? It is also called, we also call this as Bohr orbit. What is the value of Bohr orbit? Bohr orbit ki value di kaya no higher gadi 52.9 picometer. Don't forget this, okay? 52.9 picometer is the Bohr orbit. Then another point. Okay, all of you pay attention. When I ask you to summarize, you should be able to answer the question. So velocities of the electron in different orbits can also be calculated by using another important value formula, which is related as Vn, velocity in the nth orbit. So if I want to find the velocity of the electron in the Bohr orbit Bohr orbit radius of the first stationary state. So when Vn equals to V1 value 2.0188 into 10 to the power 6 because sigi z is 1 oigani sigi n is 1 oigani 1 sidi akoi multiply to matam da mang ni dana ko aduna V1 sina kya tarakadagi hai kana 2.188 10 to the power 6 velocity ki unit kaino meter per second aduna masai high pointing je I quickly summarize to makok tagi muna taro ko si I hek high level ko no higher kada bani Bohrs ki magi postulate kaya legi hai du yingsi ahan bada kaya hai gra atom consists of a small heavy positively charged nucleus in the center and electron revolve around the nucleus in a circular orbit. Then ani shubda kari hai these energy cells are given numbers called principal quantum numbers. Then ani shubagi subheading ahum leire ahan bagi points ni maru ai se ahan bagi sina energy ani subai sina radius ahum subusina velocity aduna postulate ani se phajana khangna bona gi si ko energy in the nth orbit sikananapi it is given by a formula called Rybak formula which is minus RH z squared by n squared. RH ki value khango 2.18 10 to the power minus 18 joules. Then radius ti kay manere 52.9 n squared by z. Ko adagi Bohr orbit habisina kaino ko khangre egumba z sina 1 ore first stationary state adi adum 52.9 ta gadoine adagi velocity gi value sina kanana pi vn equals to 2.188 10 to the power 6 joule per z divided by n meter per second there aduna quickly among summarize the okay what are the important postulates ahanbada atom consists of a nucleus at the center and electrons revolve around in circular path. Point number 2, the energy cells are given numbers called principal quantum numbers. Subheading point A, energy in the n orbit is given by expression En equals to minus RH z square by n square. RH की value दी क्या नो 2.18 10 to the power minus क्या लगेगा 18 2.18 10 to the power minus 18. Then radius की मतंग Rn equals to 52.9 n square by z. Bohr orbit khangani velocity na kamaina pi 2.188 10 to the power 6 z by n. So kitang confusing oi bani adubo hanjan par ka khangakani ko. So tell me the postulate of Bohr's model hero Bohr's postulate hero Cindy.
An atom consists of a small, heavy, positively charged nucleus in the center, and around it, electrons revolve in a circular orbit. Electrons revolve only in those orbits and have a fixed value of energies. They are numbered as 1, 2, 3, and are known as principal quantum numbers.
Very good. Energy in the n orbit En equals to kaya manay
minus RH z square by n square.
Okay. What is the value of RH, Rieber constant, for hydrogen atom? 2.18 10 to the power minus 18 joule per atom. Tell me about radius in the nth orbit.
Radius equal to 52.9 n square by z picometer. Velocity equal to 2.188 into 10 to the power 6 z by n meter per second.
Okay, tell me something about the velocity.
Velocity equal to 2.188 into 10 to the power 6 z by n meter per second.
Okay, very good, very impressive. So you have the second postulate. 1, 2, dagi 2 ki subheading में हम हाइबंग में अदे नुपारों दे साइटा कनान हाई नि albedo avinas ningo nupi na hen grengo kanalo ma sasat hairo competition to siko girls are very smart, they can answer quickly. So kana hire kani Devita hire kira as a representative from the boy side. Devita, will you represent the boy side or boy side ki kanana explain to kada hire nakata to sila like video on to the hi
sir
hi
postulate 1, in the center of an atom there is a small heavy positively charged nucleus, and around it electrons revolve in a circular orbit.
Yes.
And in the circular orbits there are electrons, and the energy cells are level 1, 2, 3, 4, 4, which are called principal quantum number.
Yes.
And the value of energies na En is equal to minus 2.18 into 10 to the power minus 18 into z square by n square. And radii of a radii na 52.9 n square picometer. Velocity na 2.188 into 10 to the power 6 into z by n centimeter per second.
Centimeter or meter?
Meters per second.
Ito action biya deko. 20 mo hire me 2.188 10 to the power. Very good, very impressive. Now Nakata have saved the life of boy side. Cindy and Nakata, very good, very impressive. Now picometer have say kaya gamanay meter kaya gamanay binanta hero. 1 picometer say how many meter? Binanta.
10 to the power minus 12.
Very good. Sige suffix ne prefix ne noigi like the phang thainani ko ahan unit you phakto Dinesh publication da picometer, nanometer, femtometer, octometer, zoctometer mayam laibani ko khara pasalu ko. Okay, makha chathasi postulate number Gracie, hi Giro. Anything you want to speak, Gracie? Okay, sounding well later ko si phau bada.
Nothing, sir.
Okay, makha chathasi. Problem later gadi. Okay, mathang chathasi point number 3, postulate number 3 ai ngasi Bohrs postulate se khara hairam gi lotion number to si postulate manga laibani ko. Yeah, point number 1 gi high grade, 2 gi subheading mayam high grade. 3 since the electrons revolve only in those orbits which have a fixed value of energy, hence electrons in an atom can have only certain definite of energy. So definite energy layer hai targadi moise quantity labor potneba aduna kari haini energy possessed by an electron moise quantize we hagda quantization of energy. Okay, this is called quantization of energy. Electrons cannot have any energy they like. En is equals to minus Rydberg constant z squared by n squared. Object n squared की value से होंग कोई मतुंगी ना energy से सुम होंग कदोई नेबा. अदुना electron से ना lining बा energy पंगलाई दले बिया देबा. मागी अकक ना बा energy लाइगनी बा. Okay, depending on the energy cells. So since they have a definite value of energy, kari hayani energy of an electron is quantized. Quantization की point ini point hum subuda lagi sina. Amuka hayrake energy possessed by an electron is quantized. Kaya meron gino quantized hari siya because they will have definite value of energy in a definite cell, energy cell. They cannot have any energy as they like because according to Bohrs postulate number 2 subheading A, kaya hai gi hai matamda En equals to minus of Rydberg constant z squared divided by n squared. So Rydberg constant की value high grade 2.18 10 to the power minus 18. So depending on the principal quantum number and depending upon the atomic number, you will have different values of energy. So mathali umay la eko harau reko. So depending upon the value of principal quantum number n, you will have different values of energy. So energy of an electron is quantized. So Martha is smiling because like laughing. So Martha had also what are the postulates we have discussed? Let us share your happiness.
Let one an atom consists of nucleus which are heavy and positively charged. Positively charged nucleus in the center.
I can't do I hold the happy day.
Electron energy is quantized.
You're just coming to postulate number 2. Postulate number 1 there. Kada to the hero. Postulate number 1.
Nucleus nucleus hindi ako the electron. Kuya nga like.
Nucleus Itong yung mga nucleus yaw ba? Ay wala chumi. Why the crap azalo? Atom consists of nucleus at the center and I opposite. Itong yung mga nucleus yaw ba? Heros. Atom consists of yes.
Atom consists of nucleus at the center and the nucleus electrons revolve around the nucleus and
यार ऐसे क्या होता है नकता है ग्रे सिंधी है ग्रे माठा है रे हाइनिंग बस हाथ रखा ले रही तो हम लिंथोय जे साव कौन सा लिंथोय है 631 माउंट हंग तेन साव रे हाइरोस मथांग स्ट्रेली दा हंग नहीं को स्ट्रेली रे
number 1.
postulate number 1 2 and 3 हाइरो मतलब हंग
Number 1 ꯑꯩꯈꯣꯏꯒꯤ atom ꯑꯃꯒꯤ nucleus ꯌꯥꯎꯋꯦ ꯑꯗꯣ nucleus ꯁꯤꯒꯤ ꯑꯀꯣꯏꯕꯗ electron ꯁꯤꯅ circular orbit ꯗ ꯀꯣꯏ ꯑꯗꯒꯤ postulate number 2 ꯗ ꯑꯩꯈꯣꯏꯒꯤ electron ꯁꯤꯒꯤ ꯃꯥꯒꯤ particular energy ꯂꯩ ꯑꯗꯨꯗ ꯑꯩꯈꯣꯏꯒꯤ En ꯒꯤ value ꯁꯦ minus RH Z squared by N square ꯑꯗꯨ
ꯑꯩꯈꯣꯏꯒꯤ ꯍꯥꯏꯁꯤꯕꯨ ꯀꯩꯒꯤꯅꯣ ꯅꯈꯣꯏ
ꯑꯗꯨꯒ Rn equal to 52.9 N square by Z picometer ꯑꯗꯨꯒ Bohrs orbit के मागी value से 52.9 picometer ꯑꯣꯏꯅ ꯍꯥꯏ ꯑꯗꯨꯒ ꯑꯩꯈꯣꯏ velocity ꯒꯤꯁꯤꯅ Vn equal to 2.188 into 10 to the power 6 then Z by N meter per second.
Very good, very good. And then point number 3 hairo energy of an electron is quantized. Mathang na man akoigi happy ate ko. Kayo electron se noi ginate ba. Then point number 4, yung point number 4 I explain to you. Point number 4 da hai isina kaino it is about angular momentum. Angular momentum hai bise ay mamang the classes explain to mani see momentum hai bise kaino momentum hai bise it is the product of mass and velocity. Mass and velocity ki product sibu ke hai na khangnai momentum hai na khangnai ko momentum hai bise mass and velocity ki product ne mass yam chauragadi momentum yam wang chaurani mass yam piagadi momentum yam tiktoi ne ba suppose sun ama bus na ten khalas bus ama la sigi bus ina sun ama ga humming ama ten khalasi ko there is a cow okay and there is a dog size kanan chawbe di cow ga dog se dog sine hena pi ba size ani mak sitak to ni ko kanana takte ba bus sine tak to ne ba adi kanana hena yang na pai ga gi hai ga di bus sine hena yang wang pai ni bus sina san je takko matam da kanagi momentum na pai wang ni san gi momentum sin wang ni because mass yam chaw ko ne san ji adagi hui ji di moment mai mass yam pi dana ko aduna momentum picture sumaina su khan be gari achau ga gari macha ga lamjen tana matam da gari achau bana always ngamni kai maram gino hai ga di you know mass chow ba gari chow bi mass chow idana ko same velocity se pa matam da mass chow ba kangu duna always ngamni aduna ya ga kono sidingo naya yam higa din to higa kono sidingo like energy angular momentum like energy angular momentum of an electron in an atom can have certain definite values and not any value of their own. Moina lining value they will have a certain definite values. Okay, so angular momentum diagram saying look at this person. This person is, let us say, nakatanen kalasiko. Nakata is taking a stone with a sling. Ungin is mina nungsit ungdu ni ko ungumatam da kedawi magi angular momentum possessed or ko doine nung sina radius ama describe to this radius is taken as r Suppose this stone is assumed to be the electron and the person is the nucleus. Nakatasina nucleus then kalagadi nung sigi momentum sa linear momentum or linear hagadi straight touch momentum ne sida ina p equals to mv hybrid. Angular momentum hagadi circle the legadaba. Okay, circular path the chakada angular momentum hagadi mass into velocity into radius ki concept lakadoi ko. Aduna electrons in the nucleus ki akoi bada ungdoi na angular momentum possessed already. So what is this angular momentum? This angular momentum is mvr. Aduna sida point namale high. This angular momentum possessed by an electron is equals to nh divided by twice pi. What is this n? I know n sina kay kawi sa hiro nakata kana no kang bugay hiro se n have sina kay represent kawi masay postulate number 2 diagram.
Principal quantum.
Principal quantum. Very good. H sina kay kawi hiro. What is this h?
Planck constant.
Very good. Planck constant. Magi value na kaya managi 6.626 10 to the power 2 joule second divided by twice pi. N ki value sina energy cell ki value dune ko 1 2 3 4 and so on. Then postulate number 5 sina aroi buni ay hayeng maka chathagi ko. Nasi Bohrs postulate tapolution si ko. Hayeng noi home assignment today horen group to tagalog. I will give the home assignment in the group. Okay, all of you do the home assignment. So, see the high using point number 5. When electron gain energy, it gets excited to higher energy level. Electrons in the energy gain to matamda higher energy level the excited wave. Electrons in the energy lose to matamda it gets demoted. Promotion pangaroiba, demotion panganiba. Lamheladi paikada detain ta widana ko pass ta bungam jagadi namana ba sing na promotion phangini mana detain ta hogani detain haibadi pharibani detain ki hek makha sina demote airini ko demoted haideba class 4 da tamamba satra sa chahi hum sum class 4 tamkhala adi ke doni ma class 3 da tamu haira ka deba aduna promotion phangbai musta demotion phanggadeba. So electrons in energy absorb the matam da ke dora when energy is gained by an electron, it gets promoted to higher energy state. Okay, and when electron is losing energy, it gets demoted. Haibadi stable or akadoine. Sigi point ko. So when electron gains energy, it gets excited. Okay, so 5 postulates. Remember. Okay, I'm going to give the home assignment in your group. Kung suta sa le ko, masigi di sidalo siya sa klase. Hayang continue hours. So all of you do the home assignment. Submit or ay tagalog. Okay, thank you for joining the class.